Hey y'all, it's me, Miss B. Today we're talking about graphing tangent and cotangent, and we're going to transform tangent and cotangent functions. Okay, so here we're going to start with our key points just like we did before. Notice over here to the right, I have the same values as I did before. I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. The same as sine and cosine. So let's talk about those values. So I have at 0, remember that tangent of x is y over x. So at the point 1, 0, we have 0 over 1, which is equal to 0. Pi over 2, right here, we have 1 over 0, which is undefined. At pi, we have 0 over negative 1, which is 0. 3 pi over 2, negative 1 over 0, undefined. And at 2 pi, it's 0 over 1 again, so we're at 0. So then at 2 pi, it starts to repeat itself again. So I'm going to go ahead and come down here and show what it would look like if we graphed those values. So we've got the same thing as we had before. So 0, 0. Come on. 0, 0. Pi over 2, undefined. Undefined, it means we have an asymptote. Pi 0. 3 pi over 2, undefined, so an asymptote, and then 2 pi 0. Now, that tells us nothing about the graph. We don't have really anything to show there. So we're going to have to add in some more key points. Some good key points. So at pi over 4, and if something has a reference angle of pi over 4, it's going to be a form of 1 because it's radical 2 over 2, radical 2 over 2. So at pi over 4, I get radical 2 over 2, radical 2 over 2, so it's positive 1. At 3 pi over 2, I have a negative radical 2, so 2 over 2 radical 2 over negative radical 2 over 2 is negative 1. Tangent is positive in the third quadrant, so at 5 pi over 4, oh, this is supposed to be over 4, darn it. So 3 pi over 4, change that value. So at 5 pi over 4, we have positive 1, because negative over negative is positive. And at 7 pi over 4, we have positive over negative, which is negative 1. So the reason we use those values is because they're really just ones, again, just like they were for sine and cosine. So we'll graph that in just a moment. Actually, let's go ahead and graph it now. So we've got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So it goes 0, 1, undefined. Negative 1, 0, 1, undefined. Negative 1, 0, 1, undefined. And it just keeps repeating itself. So if we graph those points, pi over 4, 1, 3 pi over 4, negative 1, 5 pi over 4, 1, undefined, negative 1, 0, and then we would have 1 back over here. So when I graph that, it's going to look like this. And it just keeps going and going and going. We can even continue it in the negative direction. Okay. So for the domain and range, the domain we'll get to in a second. The range, notice that it goes from, we're starting all the way down here and we're going all the way up. And because of that, it's negative infinity to infinity. In the domain, it gets cut off at these points here, at these asymptotes. Every single asymptote is pi away. So x is not going to be equal to, it starts at pi over 2, so we're going to write it as pi over 2 plus, and each of them are pi away, so pi and then n being the number of times. So here at pi over 2, this is pi over 2 plus pi times 0. Here we have pi over 2 plus pi times 1. So that is how we do our counting. And then at 9 pi over 4, we would have another yeah, I think at 9 pi over 4. No. At 5 pi over 2, we would have it undefined again, and that one would be pi over 2 plus pi times 2. So that's what that n means. It's just the number of times that it's repeating. All right, let's look at our graph for cotangent. So we've got our x and y, and we have, let's actually be lazy and copy these down because it's the exact same values. Don't know why that's different size. Okay. So then let's find cotangent of these values. So at 0, tangent is undefined because before we had, so at this point we have 1 over 0. So at this point it's 1 over 0. This point we have radical 2 over 2, radical 2 over 2, so it's 1. Pi over 2 we have 0 over 1, so it's 0. 3 pi over 2 we have negative radical 2 over 2, radical 2 over 2, which is negative 1. And then at pi we have negative 1 over 0, so that's undefined. And so now it starts repeating itself, so it goes undefined, 1, 0, negative 1, undefined, 1, 0, negative 1, undefined. Let's go ahead and graph that. So at 0 we're undefined. Then at pi over 4 we're 1, pi over 2, 0, negative 1, undefined, 1, 0, negative 1, undefined. Oh. Alright, and then we graph these along the asymptotes. Alright, so I just want to point something out. Notice that the point between pi over 4 and pi over 2 is, it's only one space away, and that is with an amplitude of 1. Our period, the time it takes to get through one whole cycle before it starts repeating itself, is is pi, so it goes from 0 to pi, so it's pi. And then our phase shift for this one is 0. Okay, so I think, and the same is for tangent, so it's just flipped and shifted over. The amplitude and period is still pi and 1. All right, the domain starts at 0, and then asymptotes at every pi, so it's just going to be pi n, and then the range is from negative infinity to infinity again. All right, so let's look at 3 tangent of x. So thinking about it, this is going to cause an amplitude of 3, and there's no change in here, so the period's still pi, and the phase shift is still 0. I want to copy these values again because I'm lazy. But you know what? Let's copy this whole thing. Okay, so we have our original values. This is our original x and y, and we want to transform to get our new function, which is over here. So we have x and y. There's no change in x, so these values are the same. 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Those values don't change. Y, however, we have to multiply these values by 3. So I get 0, 3, undefined, negative 3, 0, 3, undefined, negative 3, 0. And then we'll plot those points. So we have 0, 0, pi over 4, 3, pi over 2 is undefined, 3 pi over 4, negative 3, pi 0, 5 pi over 4, 3, undefined, and then negative 3, 0. So we plot that, it's going to look like so. So you can tell that it got a lot skinnier because it got pulled vertically like Laffy Taffy would. Okay. Let's look at a cotangent one. So our transformations are the same as they were before, just slightly different with the different values. So here's my cotangent values. I'm copying these so I have them for reference and putting them down here. You can copy them down yourself. Okay. What I'm going to do actually is I'm going to take this and put them on this. Okay, maybe not. Put these on this side, and then I'm going to take these and put them right here, and then we can just put the numbers in the boxes. So these are our original x and original y, and now we want our new x and y in here. All right, so let's talk about what these values are going to do. Our amplitude, so this negative out front, that's going to reflect over the x-axis. This 2 is going to stretch us 2, making our amplitude 2. To find our period, we're going to, well, this is going to go pi times as fast. And then this will make it move left. Okay, so our period is going to be, because our period before was pi, to find our new period, we're going to do pi let me write this down, to find period for tangent and cotangent, you're going to take pi divided by your b value. So pi over b is equal to pi over pi, making this 1. And then our phase shift, to find that, we set the thing in the parentheses equal to 0. So we have pi x plus pi over 4 equals 0. And solve. So we get pi over x equals negative pi over 4. So then x equals negative 1/4. Oh, that's because I put pi over x instead of pi x. This is pi x. There we go. Sorry, I'm looking at my key. All right. So I need to, for my x values, I need to divide. So we want to subtract c, then divide by b. So I want to subtract pi over 4, and then take that value and divide it by pi. So we get negative pi over 4 divided by pi is negative 1/4. Subtract pi over 4, divide by pi, and I get 0. Now, you can notice that the difference between these is pi over 4. You can keep going with that, or you can notice the pattern because it keeps increasing by the same amount every time because they're equally spaced. So we get 1/4, 1/2, 3/4, 1, 5/4, 6/4 would be 3/2, and then 7/4. Our y values, we're going to multiply those by negative 2. So we're still multiplying by a. The only difference is that it's going to flip over the x-axis. Careful that you don't write your amplitude as negative 2 because it is positive 2. Because it's the distance between the trough and the crest. So this is still undefined. Negative 2, 0, 2, undefined. Negative 2, 0, 2, undefined. Okay, so let's make this 1 and this 2. So we have negative 1/4, which that would be right here, undefined. So this is an asymptote. 0, 2, kind of got cut off. 1/4, 0. 1/2, negative 2. Then at 3/4, it's undefined. Then we start the pattern, 2, 0, negative 2, undefined. So then my graph is going to look, why do I feel like I did this wrong? Oh, because at 0, it's negative 2. That's why I have these values flipped. I also feel like I'm shifted over one. Let's actually graph here. Okay, so 0, negative 2, 1/4, 0, 1/2, positive 2, undefined, negative 2, 0, positive 2, undefined. There we go. So we have to move our asymptote over. So then our graph looks something like this. Okay, so you can see it's been reflected. Cotangent now looks like tangent, which makes sense because it's just reflected. And then our it has been shifted to the left, and it's not as visible since we changed our graph and our axes, but it has been, it goes faster now. All right, so that's it for today, folks.